IGCSE Computer Science Syllabus Statement 1.1.3b show understanding of the concept of MIDI files, JPEG files, MP3 and MP4 files. So basically this, well, I have to explain this. This is the third statement of 1.1.3, but this is the second video of it because the second statement was about error detection. So I just want to kind of go a logical order here, because the last video was file types. So this video is, file types, but more in depth and fewer file types that we have to cover. So this video is going to be more about, mostly about compression. Apart from MIDI, of course, which is all theory. It's more to do with compression. And I know that the fourth statement says something about compression, but we'll cover lossy and lossless compression there, so yeah, let's get started. So MIDI stands for Musical Instrument Digital Interface, and it's a widely used standard for interconnecting electronic musical instruments and computers. It's associated with the storage of music files, but MIDI files don't contain sounds. This makes them much smaller than other music file types. MIDI uses 8-bit asynchronous serial transmission, which means that there is a start bit and a stop bit. Now, this will require a bit of explaining if you haven't watched 1.2.1, which now, at the time I'm recording this, that is, doesn't exist yet. But it should when you're watching it, eventually if you're watching it soon, should exist. A MIDI file consists of a list of commands, actually, instructing a device which note to play and how loud to play it. That's pretty cool, actually. You just have a list of commands, like telling you which note to play, how loud, how quiet to play it. And, each command has a sequence of bytes. So there are three that we're going to be talking about. Status byte, which tells the MIDI device to perform a function, and the MIDI channel is also encoded in the status byte. So MIDI has 16 channels to operate from, and they're numbered 0 to 15, sometimes 1 to 16. And when we say a channel, we kind of mean like a medium of transfer. So you can imagine like wires, for example. So examples of MIDI commands can include note on or off, which basically indicates if a key has been pressed, and key pressure, which indicates how hard the key has been pressed. So to sort of control the volume. So the harder the pressure, the louder the volume. Then there's the pitch byte, which tells the MIDI device which note to play, and there's the velocity byte, which of course tells the MIDI device how loud the note should be played. A MIDI file has the extension .mid. This file can be played through a musical instrument. Now what makes MIDI special is, since it's a series of commands, it can be played through various musical instruments. Now that's pretty cool. So if you imagine a normal MP3 file, it just plays music, but the MIDI file you can play it through various instruments. However, music sequencer software is required to play the file through an instrument, as the file wouldn't be recognized on its own. So it's kind of linking to how software can only open certain files. Certain files can only be opened by certain software. It's kind of like that. So my chair has become really sweet. My square has become really alright, weird. JPEG. So look at these 4 photos of Mudkip, and you'll notice that as Mudkip goes right, he sort of starts to blur. Now this has to do with, the amount of pixels per centimeter. I'll explain this. Basically, this is the image that I got from Bulbapedia, the full-size image right here, which is 28.35 pixels per centimeter. That's 100% of the image. And then I've reduced it to 14.16 pixels per centimeter. So that is 50% of the original. And you can't really see it. It's like, you can only see a really slight difference if you look carefully. Here you can see a little bit more. That's 25% of the original, and this is 10%, and this is most blurry. So when a photographic file is compressed, the size of the file is reduced, but the quality of the image is sacrificed for this reduction of size. Once an image is compressed, a new file is created which replaces the original file, which means that you can't really easily revert back to the original. So that's what JPEG stands for, and it will reduce a raw bitmap image by a factor of 5 to 15 depending on the quality of the image. Now, a raw bitmap image is basically can be a TIFF, which is spelled TIFF, or a BMP, which is bitmap. So bitmap picture or whatever. So this is kind of like the original picture. Like, so files of bitmap images basically tend to be quite large compared to JPEG, as JPEG compresses them. Now once we get to lossy and lossless compression, it should make a little bit more sense to you, but for now, just stick with this. I mean, I hope it kind of makes sense. So the number of pixels of an image is calculated by length times width. For example, an image which is 1,000 pixels by 2,000 pixels would be 1,000 times 2,000, which gives you 2 million pixels, as long as my calculator didn't screw up on me. The file size of an image is determined by the number of pixels, as well as the number of primary colors the image uses. Most images use 3 primary colors, red, green, and blue. So the file size of that image would be 2 million times 3, which gives you 6 million bytes, which is equivalent to that many kilobytes and 5.72 megabytes. How did I get these values? Just divide that by 1024, divide that by 1024 to get the megabytes. So here's a question. I put a little question mark there because it's a question. So an image is 128 by 364 pixels. Calculate the total number of pixels. Easy. Just times the two numbers. So we get 46,592 pixels. Calculate the size of the file. So remember that the image consists of 3 primary colors, we're assuming. So it would be this value times 3, which gives you that many bytes, and divided by 1024 to give you 136.5 kilobytes. So calculate the size of the JPEG file when it's reduced by a factor of 7. So when we say a factor of 7, reduced by a factor of 7, it's basically that divided by 7. So that gives you 19.5 kilobytes. So you might be wondering at this point, hang on, the exam is going to be non-calculator. So how the hell are we meant to do that? Well, I'll put it this way. We might be screwed, honestly. But I'm not actually sure. They might give you small numbers. They might be understanding, unless they're really cruel and they give you large numbers like the ones we were using. But hopefully it won't come to that. Hopefully we won't even get these questions in the exam. I say we, as in I'm about to take the exam in a few months from now. Although, by the time you're watching this, I've probably finished school, whatever, I don't know. Whenever you're watching this. So, MP3, Moving Pictures Experts Group 3. Okay, what are the experts group? Are they like the Illuminati or something? Alright, I have no idea. Okay, experts group, JPEG, MPEG. What is EG? EG. Alright, so MP3 uses audio compression technology to convert sound into an MP3 format. This reduces the size of a normal sound file by around 90%, so basically a factor of 10. For example, an 80 megabyte sound file could be reduced to an 8 megabyte MP3 file. So that's 80 divided by 10. So a factor of 10. And this is done by removing sounds which humans can't hear. That's pretty cool. And this process is called perceptual music shaping. So here's another question. Music is to be stored on a CD. Each minute of music is worth 12 megabytes. Calculate how much space the CD would need in order to store 3 tracks, which are 3, 6, and 7 minutes long. So we add up the minutes to get 16 minutes in total. And then we times 12, because each minute is worth 12 megabytes. So 16 minutes times 12, which gives us 192 megabytes. The files are compressed using an MP3 compression algorithm. So calculate how much space the CD would now need. So we're assuming the file size is reduced by 90% or reduced by a factor of 10, whatever you want to call it. So 192 over 10 gives us 19.2 megabytes. So the CD has 800 megabytes of space. Calculate how many minutes can be stored on the CD. So remember that 1 minute is 12 megabytes. So we can have 800 over 12, which gives us 66.67 minutes. Or if you want to be accurate, 66 minutes and 40 seconds, approximately. Now this is the last thing, and trust me, it's really, really short. Like, it's actually just this slide. MP4 is a little bit different from MP3. Rather than only music files, MP4, I thought it was, I'm going mad. MP4 can store multimedia files. So music, videos, and photos. Now, most people associate MP4 with videos, but that's not true. Apparently you can also store music and photos, although I haven't really tested it out yet. Could the course be a lie? Find out next time on Dragon Ball Z.